Hi everyone, Christian Ramirez here. Welcome back to another maldev demo. In today's video, we are diving into something that every malware developer and red teamer needs to understand. How antivirus and EDR products use API hooking to monitor our process at runtime. And more importantly, how to detect and analyze it. Our agenda for today's demonstration is divided in 5 different phases. So we are going to start with a quick theory on what API hooking actually is and the two instrumentation models vendors use. Then we are going to go straight into inspecting two different API states inside ntdll side by side, comparing the unhooked clean bytes against the hooked version so we can clearly spot the trampoline and understand exactly what Bitdefender is patching. For this demonstration, we are going to use two different machines. The first one will be a Bingware station that only contained Microsoft Defender. And the second one is an actual physical machine that is going to have installed Bitdefender. Then we are going to jump into the actual demos. The first one is going to be using x64dbg, and the second one is WinDbg, where we will see the E9 jump instruction with our own eyes and the function prologue. Then we are going to use an automated tool called HookDefender 64 running live against the Bitdefender protected machine, where we will see Bitdefender's hooked DLL injected into the process and the hook Windows API function exported flag in real time. Finally, we are going to close with a vendor breakdown showing exactly how Bitdefenders, Sophos, and CrowdStrike each handle hooking differently and why that matters for our red team operations. Alright, let's go into it. Let's start with the definition and an explanation. What is API hooking? So API hooking is a technique where a piece of software intercepts calls to Windows API functions by patching the function's first byte in memory with a jump instruction, redirecting execution to a custom routine before the original function is ever reached. All of this we are going to see it very soon in the actual demos. Now let's jump to our second section. That is basically we are going to analyze two different Windows API functions. For the first demonstration, we are going to analyze the ntallocate virtual memory in our Windows machine where is a Microsoft Defender. We will see something similar like this. The most important opcodes that we are interested is the first lines, isn't these ones? So we will have to see a move to RCX to the register R10. And we are going to go and also to the second machine where we have a Bitdefender, and we are going to analyze this API function, the nt-adjust privilege token. And we will see that instead to have a move instruction, we will have a jump instruction in here to an arbitrary address. So this is an indicator that Bitdefender is hooking this API function. So let's jump to our machines. So for this one, we are going to be in the maldev. So we only have Microsoft Defender up and running. So we can use either x64dbg or WinDbg. So let's start with x64dbg. Let me just make, yeah, I think it's a good size. Let me open a process. So we are going to use Notepad. And once we open and everything is up and running, so the second step is go to Symbols tab and choose ntdll. And in here we are going to type and filter out our Windows API function that we are interested in. Ntallocate. In this case is ntallocate virtual memory. We just need to double click and we will see, and we are going to see and land in this section. And as you can see in here, we have our move RCX to our R10 register, right? So that is something similar that we have in here, right? And this. And after that, we have the SSN number and our syscall actually, right? So with this, we can demonstrate and corroborate that Microsoft Defender is not hooking this Windows API function. So now we are going to go to our other machine, our physical machine, where we have Bitdefender, and we are going to use also our debugger. So let's just make sure that we have the proper size. Everyone can see. I guess 11 is perfectly fine. So we go file open, notepad, and pretty much we are going to do the same. We are going to go to symbols. We're going to choose ntdll, and in this case we are going to use nt adjust privilege token, and then here we have it. So we just need to double click, and we are going to see the opcodes in here, right? Start with E9, that is basically the jump instructions in here. So we can see in here that we have jump to an arbitrary address. So this is an indicator that Bitdefender is hooking this particular Windows API. If we go back in here to our presentation, it's something similar like we see in here, right? Perfect. So now that we know and we see the difference, so we will continue with our presentation. When we are going to jump to the actual demonstration, we are going to use first x64dbg. And as we can see in here, now that we are in the actual machine that we have a Bitdefender, the next step, once we got in this position, we are going to try to follow the flow. So we double click, and we are going to see that we land in a different area. So we go in here, follow the execution. We are going to see more instructions. We scroll down. If we go to this call, we are going to see that we are in a different completely section, and we can see that we are inside of this dbhkm64.dll. So from here, I am going to use System Informer, and I am going to show you inside of memory. We know that there is this DLL that had been loaded. So one of them is the BDHKM that perfectly match with this one, 64.dll, and we know that comes from Bitdefender. We also will see another one, the ATCUF64DLL. So there is two DLLs that has been loaded by Bitdefender. But in here clearly we can see and that this DLL is the one that has been hooked this Windows function. So now I want to show you another way to track these two Bitdefender's DLL in an easier way. So for this one, I'm going to go to options, preference. I'm going to go to events, and I'm going to check these two options, user DLL load and system DLL load. Going to save it. I'm going to reopen it, and I want you to pay attention at the bottom here, and I'm going to press run, and as you can see now we are in the kernel base.dll. I'm going to press run one more time, and as you can see in here, something interesting, we just spot the Bitdefender DLL at the bottom. So you can see is Bitdefender is loading the DLL, in this case the BDHKM64 DLL, right? So this is one of the DLL that we saw previously when we were following the flow. And now if we click again one more time and run, we will see the second DLL from Microsoft, actually Bitdefender, right? It is the ATCU F64.dll. So in here we can conclude that we were able to analyze, identify what are the two DLLs, the Bitdefender, and they use to hook our API functions. Now, if we want to use also WinDbg, we can do that. So for those that are interested, for WinDbg, just need to go to let's close it and reopen it. We're going to go here, open it, file, open executable, notepad. Let me adjust the font. 14 I think is perfectly fine. Yeah. Okay. In here there is actually not too much difference, so it's just two different debuggers. Whoever feels more comfortable with WinDbg can use it. Yeah, but in here is just we are going to get to the same result. The first command that we are going to use is ntdll nt adjust privilege token. ntdll nt adjust privilege token. Okay, it's missing the n. Okay, and as you can see in here, we have our jump instruction, right? Is clearly is we can see the same that we saw on using the previous debugger. So, but if we wanna continue follow the jump instruction, so we will have to use the u command. So the basically is the u command is unassemble. So we are going to unassemble the address. In this case, we are going to use this address to copy and paste it. And in here, we can see that we have a call function, okay? And we are going to now go to that function. But before to do that, we need to reload and load all the symbols for all the modules, and that way will be easier. I'm going to do it very fast, and I'm going to execute lmd just to see the modules. And as you can see in here, we have our two DLLs that come from Microsoft, no, sorry, Bitdefender, and they are the two ones that we saw with our previous debugger. the ATCUF64DLL and the BDHKM64.dll. Notice that it comes from export symbols, right? So now that we are going to continue, and the next step will be difference the call pointers. So we are going to do that with the command dq, and we are going to use this address. I'm going to copy and paste it. Okay, and this is the address that we are looking for. So now as you can see in here, we got a new address, right? So basically why we are doing this is because the hook routine calls through a function pointer, which is stored in this particular address. So, and we need to obtain it, right? So yeah, now we are going to follow the call destination. So we are going to use it and execute it with the u command, and we are going to copy this address. Okay. Okay. And yeah, and as you can see in here, and this command read the first byte of the address, getting the real destination, right? So, and in here, and we see also this push instruction, right? And we see this the return to the 100H, right? Basically, is once we disassemble, what is actually being called is we see the push FQ, and we see that the memory check and the return 100H. This is the trampoline, the stuff that decides whether to allow or block the API call. So now, and the next step is to identify the memory region. So we are going to use command address, and we are going to use our previous address in here. Just copy and paste it and execute it. Yep. And basically, in here, what we are seeing is that Bitdefender is allocating executable memory and runtime to place its trampoline code outside of the name module. Right? This is a common technique to make hook trampolines harder to detect. In here, as you can see, we are seeing in here is preparing, right? And then finally, and we can also list all the hook exports. So we can do it with the command X and the name of the DLL BDHKM64. And as you can see in here, we are listing all the export functions, right? So, and in here we can see and determine that Bitdefender and has different function, right? For this one is where I start the hooking process, right? The inline hook, install inline hook, install inline. This one, the 18 is the hooks via import address table, right? At yeah, at and this one is the one for the hooks via export address table. Let me see what is install. I cannot see install. This one install inline hooks is the one that installed the E9 jump hook. The instruction that we saw at the beginning. in here, right? Okay. As we can see, basically Bitdefender support inline hooks, import other hooks. Yeah, an alert, no problem. And also pointer hooks is kind of like a full hooking framework. It's not just using a single technique. So for this, we are going to move on. Now that we saw all of this, the next one is to go to a live demo again using hook Finder 64. We are going to run it and both machines. We are going to see the difference. So let me close this one, and I'm going to execute it. I already have the command in here, and I'm going to execute it. And as you can see, the machine that where we have Windows Defender, and we don't see hooks. The only Windows API hooks that it has been hooked is the NT query system time, right? Now, if we jump back to the machine when we have Bitdefender, we are going to see, I already execute that one. I'm going to relaunch it. So as we can see in here, when we relaunch it against the ntdll.dll, we have quite amount of information. Even the tool is able to tell us exactly the name of the DLLs. So in here, we demonstrate the way how to spot this DLL manually with two different debuggers, and also we can use this automated tool. We want to do it very fast. And also, if you were wondering why we were using the NT adjust privilege token Windows API, is because I already know that Windows API was hooked by Bitdefender. Yep. So it's in here how I see the difference between software solution that hook the Windows APIs compared with Microsoft Defender that doesn't, right? At least not in the same manner. So let's move on. So basically, in this demonstration, we saw Bitdefender, right? And we saw two different DLLs, but the DLL that hooks all the Windows APIs is the BDHM64 DLL, right? And we can see in this case, and we saw different Windows API, right? And we saw the opcode, the E9 JMP, the trampoline, and the prologue, right? Basically, that indicator has been hooked by Bitdefender. So for Sophos use the same technique, right? Different DLL, but the main reason why I want to show this slide is because CrowdStrike is kernel only. So CrowdStrike do not use Windows API hooks and the user LAN. Everything is through the kernel mode. So the approach will be different if we want to evade or bypass it. But I want to show you the difference between the products, right? And yeah, if you want additional breakdowns, source code for this example, or hands-on operation training, join to our Discord channel at RBT Security. If you are enjoying these videos, make sure to subscribe so you don't miss the next attack demonstration. Your support helping us continue producing more cybersecurity content every week. If you found these techniques interesting, please share this video with your friends, teammates, or anyone in the cybersecurity community who might want to level their skills. See you in the next one.